Hello everyone. I am giving you some more notes. I know you just got some a few days ago from me, but I wanted to give you some more notes that will help you on your final exam. I know that you can take the final a couple of times and that each time you do it, you get to kind of see through that productive struggle process, you get to see what you got right, what you got wrong, and that's all part of the process, right? So you do, you see, you learn, and then you do again. I did mention previously that productive struggle can be a little frustrating for some of you, especially if you're used to just, studying and then getting something right the first time. But really with this kind of math, especially when you're trying to refresh yourself of things that you learned years ago in some cases, it really does just help to get exposure. And that's why those assignments are set up for you to take multiple times. And just really kind of try to embrace that productive struggle so it doesn't become a frustration point for you. So what I thought I would do is go over some of the basics that I think are going to be super helpful for you on the exam. And this is for your final. There's a couple of questions from each of these different sections. And so I tried to get the highlights of things that would be most meaningful for you. The first thing that we're going to start off with is equivalent fractions. And I've mentioned a couple of times to always make sure that you're very attentive to the instructions. What are you actually solving for? What is the actual goal of the problem, to make sure that you're not solving when maybe you're just identifying something, or you're not solving for a solid number at the end. You may be writing an equation or an expression. So just always really make sure that you're attentive to the instructions, which leads us to the vocabulary, because you of course want to make sure you have those right words and you know what they mean. And then finally, before I jump into this, just remember that also printing some of this material might help you, because if you print the notes and things in front of you, it makes it easier, especially if you have one screen, so that you have those notes in front of you while you're looking at the problems on the screen. So the vocabulary that we want to start off with is when we talk about equivalent fractions. So essentially we have to know what the fraction is. I mean, most of us kind of know what a fraction is, but what's the actual definition? It's a number that shows part of a whole. So it's part of the value, not the whole thing. An equivalent would mean the same exact value. So when we're dealing with equivalent fractions, we're talking about fractions that have the same value. They show the same part of the whole, but they might not look the same. So if you're going to make equivalent fractions, here are the steps for you. Again, I'm not just going to read for you. I will pause, I'll let you read, and then I will encourage you to print this. Of course, I'll walk you through the steps with the problem below. So I'll give you a moment. Okay, so you can see here that, again, there's some vocabulary clarified for you in step 1. The top number is your numerator, the bottom number is your denominator. Always make sure you're attentive to that in the questions and the problems. And then, of course, the fraction might look different, but they mean the same thing. So, for example, 1/2 is equal to 2/4. They're both 1/2 of a whole, but they just look differently. So how do we simplify fractions? So that might be some of the instructions that you're asked to do. Well, simplify means you're going to make the fraction as small as possible. So for example, if we had 2/4, we know that we can go smaller to 1/2. So 1/2 would be the smallest version of that fraction. So the smallest or the simplest. And then greatest common factor, you'll see that written as GCF a lot. That's the biggest number that divides into both the numerator and the denominator. So what number can equally go into the top and what number can equally go into the bottom? That's going to be your greatest common factor, or GCF. So if you're going to simplify, you're going to find the GCF of the top and the bottom, and then you're going to divide by that number. So let's look at a couple of examples. So if we look at 8/12, the biggest number that will go into both 8 and 12, and you could do this by just testing it. You might know some right off the top of your head. You could use a calculator. There might be some trial and error, but when we do the math in our head or a calculator, we come up with the GCF being 4. That means 4 is the biggest number that will go into 8 and will go into 12. So 8 divided by 4, which is your GCF here, and 12 divided by 4, which is your GCF here, and that comes up to 2/3. Why? Because 8 divided by 4 is 2, and 12 divided by 4 is 3. So your answer is 2/3. And then there's another example for you. Again, value in printing this out is that even if you have different numbers, you can still follow these steps. So what if you have to add and subtract fractions? So first of all, we want to know what our common denominator is, and that's going to be that when you have the same bottom number in both fractions. So for example, 8/12 and 9/12 has the same bottom number in that fraction, so that's a common denominator. That would be an example. So if we're adding and subtracting fractions, these are the steps that you're going to follow. Again, there might be different numbers than I have on the screen here for your problems that you're solving, but these are the steps you're going to use. You first want to get the denominators to be the same, and then you're going to add or subtract the top numbers. The bottom denominator or the bottom number will always be the same, and then you simplify. Always make sure you simplify, because if you don't, then that could trigger a wrong answer just because you didn't take it all the way down. That's kind of the good thing about having these quizzes and tests that you can take multiple times, because if you do forget, if you overlook something, you can just go back and check that. I always say just check your math first. It might not be that you follow the wrong steps. It might just be a simple error. So for example, if you came up with 2/8 and you put that into your online quiz or test and it came back as wrong, go ahead and just check that for simplification, which it can be simplified down to 1/4. So let's look at some exponents basics now. So this will be on your final exam where you have to deal with exponents and you're going to be manipulating them. So let's make sure we have our solid vocabulary in our back pocket before we get started. When you're dealing with exponents, you have a base and you have an exponent. So the base is the number that's being multiplied, and the exponent is how many times that base is being multiplied by itself. So for example, the base of 2 with the exponent of 3 means 2 is being multiplied by itself that amount of times. So the exponent 3, how many times the base, which is 2, is multiplied by itself? That's the 2 to the 3rd power example. So it's not 2 times 3. That's the biggest thing to make sure you don't do. It's 5 times 5, 2 times 2 times 2, and so forth and so on. I think you could probably see that pretty easily. But here's a couple of more examples. The distributive property is also on your final, so I wanted to kind of review that one more time with you. To distribute, that's basically you're giving out each term inside of parentheses, right? So you're taking all these terms that are inside the parentheses and you're giving them out, and so that you can get them out of the parentheses. So what are the steps that you're going to follow? And this is also where PEMDAS might come in handy. If you remember those first set of notes that I gave you, again, having these printed in some type of math notebook or folder might be helpful, because you can just refer back to those notes that I gave you in that lesson. So you're going to start with multiplying the outside of the parentheses by every single number inside, and then add or subtract the results. So I think looking at an example in this case is helpful. So you're actually multiplying 2 times 3, and you're multiplying 2 times 4. And then you're going to add. So you don't add first. You multiply, and then add. So you multiply, add. That equals 6 plus 8 equals 14. Again, one of those examples that are pretty easy. The math numbers are not complex. So you could have this in front of you and you just take out the new numbers and or the old numbers and put in the new ones if you're solving a problem with new numbers. So solving equations. This is probably the most challenging, or systems of equations is probably one of the more challenging concepts in this class. So let's just review the vocabulary before we hop in. So a system of equations means basically 2 or more equations with the same variables, so that makes it a system. System might seem a little complex. It's really not. If we take the word system out and just say 2 or more equations with the same variable, it doesn't sound as scary. The solution here is we're not solving for necessarily a number. We're solving for a value that makes both equations true. So you have two equations and you want to make both of them true, which means, say we had 2 plus x equals 5. What is 2 plus x? You have to solve it. What would make 2 plus whatever equal 5? It's going to be 3. But if you have another equation with x in it, the same number has to make that equation, or that number has to make that equation true as well. So there's different ways that you can solve systems of equations. Here's where it's super helpful to have these steps out in front of you and a sheet of paper, because when you're solving them, you may have to go back and plug things in. So it's not a linear process. You may have to solve and then go back. So it definitely helps to have scratch paper and the notes in front of you. So when you follow these steps, you'll see that you're solving one equation for the variable, just like we said, 2 plus whatever equals 5, right? So 2 plus 3 equals 5. So you're solving that first equation. Then you're going to plug that answer into the other equation. Then you're going to solve your second variable. Then you have to go back again and plug it in to find the first variable. So here's an example. If you have x plus y equals 5, for your first equation, and your equation 2 is x equals 3, where do we start? Well, we go back to our steps, right? So have these out in front of you. So you're going to plug your x equals 3 into equation 1. So equation 1 was 3 plus y equals 5, but we know here that x equals 3. Step 2, y equals 2. So therefore, your solution xy is 3 and 2. So you're plugging your x equals 3 into equation 1. And that's where you get the 3 here. So this would be a 3. If you block that x out, it would be a 3. Why is it a 3? Because your equation 2 tells you that. So you're going to solve for y, right? And then therefore, you understand now what the total would be in step 2 is 2. And then if our solution is x and y, well, we already know x is 3, right? Because it told us. And y is now 2. So you're just filling that in. Okay, I am going to close this out and I'll post a couple of more videos. I'm actually going to ask some folks if there's a couple of concepts that they would like me to do a video for. I also want to just remind you, if you want to use Khan Academy, it's a super great set of videos that's used around the world by math teachers and math students. And essentially you could just go into Google and say Khan Academy, that's K-A-H-N, and then you type in the type of equation that you're doing and you get notes and practice quizzes and videos. And so obviously, there's 30 something of you. And so what one person needs, the next person may not. So that will give you a more personal access to some step-by-step videos that you can pause and follow. I hope you have a great day.